Hi there, my name is Roger Parada, and today we will be simulating a titration in Excel. And specifically, we'll be doing a strong base versus a weak acid. That is a weak acid titrated with a strong base. And central to this will be our charge balance equation. So you'll set up a charge balance equation equal to 0. And then you will put that in terms of H plus and alpha values. Note the alpha 1, and that OH is in terms of kW divided by H plus. So here is setup, and you'll see that the two tables I've completed have this graphed out, and I've erased this one just so we can see what happens if we fill it in. So I've already set up some values in this upper area. Note the Ka of acetic acid, which is the acid we're starting with. And here is the volume of NaOH added. Note how we go up in smaller increments as we get closer to 100. And once we get there, we depart from 100, which is our equivalence point, to away. Once we depart from there, we slowly increment away, and then get there, and we'll stop at about 140. That should be more than enough excess base. And then we have this column right here for the total volume, and since we're starting with 100 milliliters of acid, we do 100 plus this cell right here, which is 0, plus 100 plus 10, 100 plus 20, and so forth. And so we've set up H plus, alpha 1, our charge balance equation, OH minus, POH, and pH. So all of these are going to be centered around our pH value. So we'll guesstimate a pH value, and we'll put something like 2. We're just guessing. We can fix that later. H plus is based on 10 to the negative pH value. Alpha 1 is Ka value divided by H plus value divided by Ka. And note the dollar signs on the Ka value. And anytime we set up an equation where we don't want this value to change, we put a dollar sign on that cell value, and that just means absolute reference. And we do want the H plus to change as we go down, so that one will not have the dollar sign. Our OH, which will be Kw minus the dollar sign, divided by H plus. POH, simply negative log of OH. And then our equation, which is simply our charge balance equation that we saw right here in red. So you're going to want to set that up in that cell and put parentheticals where you need them. And you're going to want to put the entire equation in parentheses and then square it. And this ensures that we don't have any negative results. And we're going to include this multiplier. This is 10 to the 10. So we're squaring the equation and then multiplying it by a very large number, 10 to the 10 in this case. And that's just so Excel doesn't round down any values to 0 in case they're too small. And so we fill these in, and they're all going to give the same value. since, well, except for the equation, I suppose. But we'll fix this in a bit. And so what we want to do is we'll have a cell here for the sum of our equation column. Close parenthetical. And what you want to do, you'll have values very large, and the ones for the other tables are very small. This is 2.46 times 10 to the negative 5. This one's to the negative 7. So what we want to do is click the cell, data, and you're going to want to add solver to Excel. If you don't have it, just look online how to add solver to your Excel. And you're going to click on solver. I'm not going to go through it right now because it's a tedious and long process sometimes, but essentially you're going to change, you're going to want to minimize the sum value, this value right here, by changing your pH row. So you're going to put minimize sum this cell by changing this column for the pH, and you're going to do it several times over with solver until the sum value becomes small and stops changing as even when you continue to run solver. It's a little bit tedious, and that's going to take a while since I've already run it, but it's going to give us something similar to this. We're going to see our sum value become very small, and your pH values, as you can see, will become between 1 and 14, which is what we should expect. And then we can insert our graph and set it up so that the x-axis is our volume, y-axis is our pH. And done this here as well. It's completed here. You can see our value is small here. And here is our graph. So what constructing this by a balance equation does is that it helps us set this up accurately without mistakes. If you don't do this based on charge balance but use F values, you'll find that around the equivalence point you're going to get some very strange answers. Your pH is going to go up even though you're adding base. Your pH is going to go where you expect it if you do it based on F values, but it's only going to be around the equivalence point, so it's going to give you some really strange answers if you base it off F values. But if you use charge balance, you shouldn't run into the problem. And the same thing, more or less, works for a weak base with a strong acid. And here's that graph. But this one isn't based on concentration, but rather pKa. But this is the equation for a strong acid, weak base titration curve. And you just fill in the appropriate ions. And just for fun, here's a picture of me when I went to see Star Wars: The Last Jedi, and I look very nerdy, but I was happy. Anyway, I hope this video was helpful.